Hey, if you are new here, this is Chandan and you are watching the learning field. Okay, so today in this lecture we will read a new topic. Okay, we will read an interesting topic for CSIR NET. Okay, this topic is for CSIR NET, and the name of this topic is reliability theory. Okay, reliability theory is more reliable for the statistics students, but if you are a student from mathematics background, okay, so I think these topics are very easy for mathematical students also. Okay, so read this topic carefully, and I think you will be you can gain 4.75 marks very easily in the CSIR NET exam. In every year there is a questions from reliability theory of 4.75 marks. And you can think that only 4.75 marks you can skip it, and if you think then you skip it, but I think this topic is more easy to gain 4.75 marks. Okay, there are some limited topics, limited contents, and if you read these topics or this content carefully, then you can gain easily a 4.75 marks question. Okay, so let's start, and before starting I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. Okay, so there are basically two types of questions makes in the CSIR NET exam. Okay, so we will discuss those type of questions, 2 or 3 types of questions mainly for the CSIR NET. Okay, so let's start. So first we read the definition of reliability theory. What is reliability theory? So see, reliability theory more likely as the resistance. Okay, those topics we read, I think in class 10 physics or class 11-12 physics, the resistance chapter. Okay, the resistance series, case parallel, series system of resistance, parallel system of resistance. This chapter, that is the topic reliability theory, more likely with that topic. Okay, the resistance and mix, we will read it in this chapter. Okay, mix, that is series, whether series and parallel system are mixed in a system, we write this type of questions and solve this type of questions. Okay, so definition: the reliability theory of a system is the probability that the system does not fail before a given time. Okay, that means what? Suppose you buy an LED lamp and for the home. Okay, so up to the time the LED bulb will working properly. Okay, this is called the reliability, okay, of this component of this bulb. Okay, this is called the reliability. There is a certain probability that if you buy the LED light, then the all the companies are give you 1 year warranty. Okay, so you can think that this LED bulb obviously glow for 1 hour, 1 year, obviously at least for 1 hour. Okay, and but in case the bulb will be fail for one before completing the 1 year. Okay, this case may be happen, but most of the cases the LED bulb glow for more than 1 hour. So up to that time the LED bulb glow, this time or this the probability is called the reliability. Okay, so the reliability of an object can be calculated by using the probability distribution. Okay, mainly exponential family of distribution play the most important role in this topic. Okay, so the most important topics is family of exponential distribution. Okay, those who are not seeing this exponential distribution, I'll request that you just take any probability book and just go through the exponential distribution, the mean and the variances of the exponential distributions. Okay, so the probability of failure before time t is denoted by ft. Okay, this is very important term. Then rt equal to 1 minus ft. Rt means the reliability. Okay, this is failure, this is reliability. Okay, the reliability function of the system is the probability that the system does not fail before the time t. That means suppose 1 year, before 1 year the LED bulb does not work properly. Okay, that is does not fail. Okay, so this is called, the probability is called the what? Reliability of the component or of the bulb in this case. Okay, so the function ft is the cumulative distribution function of the density function ft. Okay, so the quantity lambda t equal to ft by rt is called the failure rate. Okay, that is ft equal to probability of t, capital T less equal to t. This is equal to integration 0 to t fs ds, whether t greater than 0. This is the failure and this is the reliability. Okay, so reliability equal to probability of t greater than t is equal to integration 0 to infinity fs ds is equal to 1 minus ft. Okay, so ft plus rt equal to 1. This is the total probability. One is one part is failure and one part is reliable. Okay, total probability 1, you know that. So t be the failure time of some devices. Okay, so there is another formula, mean time to failure. Okay, this is new topic, but you think slowly, I think you will be understand this topic. Okay, because this is a very easy topic and understandable topic. Okay, so exponential of t, this is equal to integration 0 to infinity t ft. This is the simple formula of exponential. This is equal to 0 to infinity rt dt. Okay, so now let us comes to another topic, another important thing, which is hazard rate function. This is the most important thing in the reliability theory. Okay, the questions, two types of questions. One question based on this hazard rate function. Okay, so what is hazard rate function? Hazard rate function is normally denoted by ht and is defined by ht equal to limit t tends to 0 r of t plus delta t minus rt by delta t into rt. Okay, so this is equal to clearly minus d ln rt by dt, which is equal to ft by rt. You just remind this thing. Okay, ht equal to ft by rt. Okay, this is the definition and you have to remind this thing. Okay, or you have to remember this thing. Okay, so some important relation, these relations are very important, and if you remember this relation, then you are done. Okay, you can get opportunity to get 4.75 marks in the CSIR NET exam. Okay, so one is ft equal to minus drt by dt. Okay, and number 2 is rt equal to exponential of minus integration 0 to t hx dx. Number 3 is ht equal to hazard rate function equal to 1 by rt into minus drt by dt. This is equal to minus dln rt by dt. This is equal to ft by rt. Okay, and number 4 is ft equal to ht exponential minus integration 0 to t hx dx. These four relation are very important relation. Okay, very important relation. Okay, now the two types of problems are mainly, one comes from hazard rate function and another comes from system reliability. That is, you have to calculate the reliability of a certain system which are provided in either series form or parallel form or the mixed format. Okay, so how to calculate the reliability of function? Okay, so to calculate the reliability of a function system, we need to know the reliability of the component and calculate the probabilities depending on the depending on whether the components connected in the series or parallel. Okay, suppose in your home there are we will know that, obviously we will know that our home electricity, that is the components in our which we used in our home, are connected in parallel formation, parallel series, parallel system. Okay, so for case of parallel, and the example for the series system is the chain light. Okay, which we used in the Diwali light. For the Diwali light, the chain light, is in the chain light there are series system used. Okay, so these are two examples of the series system and parallel system. To calculate whether we need to know whether the components are in series, whether components are connected in series or parallel. Okay, so number 2, if the components from of the system are connected in series, then we must multiply the probabilities of the survival time of the components. Okay, survival time means the time in which the light glow, that means the light or the system does not fail. Okay, this is the survival time. Okay, and number 3 is if the components of the system are connected in parallel, then we multiply the probabilities of the failure of the components. Okay, this is the failure and this is the in case series, we have to multiply the survival components, probability of the survival components, and in case of parallel, we have to calculate the failure of the components. Okay, so these are the important things you have to remember this. Okay, now we comes the series system. Okay, so series system of reliability function. The series system of reliability function is denoted by normally or generally RST. This S stands for series, and this is the function of suppose T, and this is equal to product of each component, reliability of each component. Okay, suppose there are n components connected in series. Suppose there is an example I take, there are 3 components, okay, which are connected in series. Okay, that means the reliability of this total series system, this is equal to the product of reliability of these three components. Okay, so this is equal to 1 minus product of RIT, this is equal to product of 1 minus FIT. Since we know that FIT, that is the failure plus the reliability, that is the survival time, this is equal to total 1. Therefore we can write RIT equal to 1 minus FIT. Okay, so this is the formula, and this formula is very important, you have to remember this. Okay, where Ti is the failure time to the ith components and RST is equal to R1T, R2T, Rnt if there are n components. I take an example for 3 components. Okay, this is a series system. Now there is an important note, the hazard rate function. Okay, the hazard rate function HT equal to product of HIT. Okay, this is an important result or note, you can say. Okay, now we comes to the parallel system. So parallel systems we denoted by the reliability of the parallel system is RPT. This P stands for parallel. Okay, so this is equal to 1 minus FPT. Okay, F for failure with each component. Okay, so this is equal to 1 minus product of FPT means what? FPT means 1 minus RIT. Since FIT plus RIT, this is equal to 1 for each component. Okay, so this is the formula, you have to remember this. And if we take this example, see there are 3 components connected in parallel system. Okay, so this is an example you can take where FPT equal to probability of P less equal to, this is a formula which we read in first of this class, is starting in this class. So this is equal to F1T, F2T plus Fnt. Okay, up to Fnt, this is the product. So this is in case of parallel, the product of failure of each component, and in case of series, the reliability, that is the success probability, product of the success probability of each component. Okay, so this is the thing you have to remember. Okay, just this is the thing, and this is the small theory part. Okay, of reliability theory. Okay, based on this theory, just these small topics, the questions comes in CSIR NET. And now we covered the different types of questions comes in CSIR NET. Okay, in this lecture we will cover the questions comes from based on system. Okay, so see example 1, a system consists of, and in the next lecture we will cover the question based on hazard rate function, which are more important. Okay, for CSIR NET. Okay, this questions is also for CSIR NET. Okay, so see, a system consists of 3 components arranged as in the following figure, each with reliability half. Okay, then the system reliability function is, so there are 3 components, see this figure. Okay, so there are 3 components connected in this type. So these 2 and 3 are connected in series, and this 1 and this 2 are connected, this one, suppose this is 1 component and this is 1 component, these 2 components connected in series. Okay, so this is the example of a mixed system. Okay, this is the example of a mixed system. Now we have to calculate first, for this type of problems we calculate the reliability function with a general reliability. Suppose the general reliability is P, which is a probability. Okay, so for this type of problem we always take the general reliability, and then we calculate the reliability function for the system and then put the value. Okay, we in all types of problem, this type of problem we follow this process. Okay, so let each 3 component has reliability P. Okay, so these 3 components are reliability P. Now RS, that means the probability of these 2 components is connected in series, and we know that what we know that RST, that means reliability equal to product of these 2 reliability. Okay, so product of what? Product of reliability, that is success probability. So P is the success probability which is given in the question, that is reliable. So system is reliable, so RST equal to P into P is equal to P square. Okay, so this is P square. Now we have 2 systems with reliability, this and P square. So P and P square connected in parallel. Okay, these 2 components connected in parallel. Okay, this is the system and this is it. Therefore RPT, so this is the total reliability of the function, which is equal to the formula. Just we read 1 minus product of, suppose there are I equal to 1 to 2, so product of I equal to 1 to T, 1 minus RI. This is the formula. This is equal to 1 minus C, 1 minus R1T into 1 minus R2. So this is equal to 1 minus what? 1 minus R1T and 1 minus R2T. Okay, 1 minus R12 means this, and R2 means this. Okay, you can interchange it, there is no matter. Okay, so 1 minus R1t means 1 minus p, and the second one is 1 minus p square. Okay, this is clear. I think this is clear and very easy problem. So this is equal to, and we have to calculate where for the value p equal to given in the question is half. Okay, so we just put the value of p is equal to half. So rp at half is equal to 1 minus, this is simple calculation, and if we calculate, this is 5 by 8. Okay, so this is a question comes in CSIR NET. So the correct answer is 5 by 8, option number B. Okay, these two, there are two question mixed in CSIR NET. One is this question given a general value p, and one is this question. There are two questions mixed in, I mixed these two questions in one question. Okay, this is a question, the question asks that what is the reliability function when the system reliability, each component of each reliability is p. Okay, this is one question, and there is the question I write here, it is number 2 question. Okay, so these two questions are of CSIR NET. Therefore we covered two questions of CSIR NET. Now let us come and another example which is also questions of CSIR NET. Question says that a system of 5 identical units consists of two parts A and B which are connected in series. Okay, so A and B are connected in series. Part A has 2 units connected in parallel, and part B has 3 units connected in parallel. Okay, so part A and B are connected in series. Part A has 2 components which is connected in parallel. Part B has 3 components which are connected in parallel. Okay, all 5 functions independently with probability of failure. Probability of failure, I repeat, probability of failure is equal to half. Then the reliability of the system is. Okay, so probability of failure given. So this is the picture of the system. Okay, this is suppose part A, this is the left side is part A and right side is part B. Okay, part A and part B. Part A are 2 components connected in parallel, part B has 3 components connected in parallel, and these 2 parts connected in series. This is the picture of the system. Now given in the question is probability of failure, therefore we let assume the probability of each component has failure probability p. Okay, therefore success probability what? Success probability is 1 minus p. Now we calculate the reliability of part A and reliability of part B, then we calculate the reliability of the total system. Okay, so reliability of part A, this is equal to the parallel formula, 1 minus probability of 1 minus RIT. This is the formula for the parallel system. So this is equal to, and C, this is RIT, that means given, we have given FIT, this is equal to P. Therefore RIT equal to what? RIT equal to 1 minus FIT, this is equal to 1 minus FIT, this is equal to what? 1 minus P. So this is the success probability. Therefore we put the value 1 minus P into R1 into R2. Okay, so 1 minus R1t and 1 minus R2, and R1 and R2 with the same success probability 1 minus P. Okay, so this is equal to 1 minus P square. This is equal to 1 minus P into P. This is equal to 1 minus P square. Okay, so this is the reliability of the system A. Now for the system B, the same formula, 1 minus probability of, there are 3 components, therefore the summation, the product goes from 1 to 3. Therefore 1 minus R1t, 1 minus R2t, 1 minus R3t, and R1, R2, R3 are the probability, success probability, that is 1 minus P. Okay, so 1 minus P, 1 minus P, and 1 minus P. This is equal to 1 minus PQ clearly. Okay, now we get the reliability of part A and part B. Now part A and part B are connected in series system, and for the case of series system we just product the two reliability. Okay, so RST equal to RA into RB. So this is equal to 1 minus P square into 1 minus PQ. Okay, so and we have to calculate with what? P equal to half failure, that is P equal to half. This failure we assume the failure probability half, so we just put the value P equal to half. So RST equal to 1 minus 4 into 1 minus 1 by, this is equal to 21 by 32. Okay, this is the answer, and these are the questions from CSIR NET. Okay, so 21 by 32, option D is your correct answer. So how was the topic? If the topic is easy, if the topic is helpful, then comment me in the comment section below. Obviously comment me, because this is a new topic from, I think, for all the students. This is new topic. For the stat student, I think this is reliable, that is, this is their own topic, but for the math student this is a new topic, and for stat students, some stat students, so this is also a new topic, and this is, I think, very easy topic. So how was the content, how was the lecture? Obviously comment me in the comment section below. Okay, if you like the content, then please give a like to this video, share with your friends, and subscribe the channel. Okay, thank you, see you again in the next video.